0.7 over negative 0.0244, and 0.7 is not a cube, okay? And you should have the answer for the time. Question D. What is the half-life of iodine? We haven't explained the concept of half-life yet, so let me use this example to talk about half-life. Half-life is the time needed to cut the original amount to a half. Half-life time to cut the original amount to half. Okay. So our formula is right here. We're going to do the exact same thing that we have right here. Half-life means the time to cut the things into a half. So the future amount is, the initial amount is 100. The future amount is going to be 50, right? A half. How long does it take to bring from 100 grams down to 50 grams? So you do the same things, divide by size. Instead of 0.7, you got 0.5, 0.5 right here, 0.5 right here, and divide by the rate, and you have. So in general, T half-life is going to be ln of 0.5 is half, okay, divided by the rate. 0.5 for a half, I want to write a half, 0.5, okay, divided by the rate. That's going to be the half-life formula. We have it before, so we'll do the same thing right there. And the bottom right here is the rate. Okay, let's move on to another example. Next time we're talking about Sir Isaac Newton's laws of heating and cooling. Alright, so this is the problem. Let me look for it. Time for cooking and cooling a pizza. Pizza is baked at 450 Fahrenheit degree. So small. It is removed from the oven at 5 p.m. and placed in a room that is a constant temperature of 70. So first of all, let me write out the formula. UT equal to big T plus U naught minus T times E to the KT. That was the formula, right? And they say what? A pizza is baked at 450 Fahrenheit degree. Means what? The original temperature for the pizza U naught is 450 Fahrenheit, and it is removed from the oven at 5, placed in a room with a temperature of 70. So big T is equal to 70 Fahrenheit degree. This is the room temperature. That's what we have. Okay. 5 minutes after, the temperature of pizza is 300 Fahrenheit. So U of 5 now. Let's talk about minutes. Okay. 5 minutes is equal to 300 Fahrenheit. This is minutes. They say that after 5 minutes, this is the future temperature of the pizza, UT. So 5 minutes later, U5, the temperature of the pizza after 5 minutes is only 350. Of course, saying what? The temperature of pizza is cooling down, right? 300 is still hot, but it's cooler than 450. Okay, that's all we have. Then at what time can you begin eating the pizza if you want the temperature of pizza to be 135? At what time can you begin eating pizza? So you want the temperature of the pizza to go down to what? 135. So let me try to get some information from this much of the information that the problem gave me. So I know that what? 5 minutes later, 300 is equal to temperature is 70 right here, plus 450 minus 70 raised to the power of e to the k times 5. You know why I write 5 right here? Because say what? 5 minutes later. This is U5. Okay? So I see that I got all the numbers except for k, so I can calculate the rate of decreasing the heat decreasing. Okay, so what we have right here. 300 equals 70 plus, this is 450 minus 70, I can simplify, this is 380 times e to the 5k, okay? Of course, I can subtract the 70 in both sides. Remember what I wrote before, instead of write 70 right here, usually I write what? This one is the same thing, ut minus t is equal to this, right? We'll add the t on this side. So if you write the other side, you have the 300 minus 70 right away, which is 230, I think. Is equal to 380 times e to the 5k. 5k, not t. Now what? Divide both sides by 380. So 230 over 380 is equal to e to the 5k. And you see what the k, the constant rate, the rate of losing the heat is going to be a constant. And this other exponent, we solve for this, we apply log of both sides. I can simplify, take out the 0 top bottom. So ln of 23 over 38 is going to be equal to 5k times ln of e, which is 1. So k is ln of 23 over 38 and over 5. See what we got? ln of 23 divided by 38, everything divided by 5. Oh, it's about 10%. Negative 0.1004. So it's about negative 10%. It means what? Every minute, the temperature of the pizza is going to lose about 10%. Okay, so I got the K. It's a constant, so I know this. And the question tells me this. In order to be able to eat the pizza, you need to cool the pizza down until you have to wait until the temperature of the pizza cool down to 135. So they ask for the time. How long you have to wait until the temperature of the pizza is going to go down to 135. Now you apply the same formula, but you have K solved. K is about 10%. Negative 0.1004. That's about that. And you want to calculate time. So this is 135 that they give you, 135 Fahrenheit. Okay? Whenever the temperature of the pizza will cool down to 135, then you can eat. And how long do you have to wait? Minus 70 is the room temperature. I don't need this because I used T on that side already. This is what? 450 minus 70 right here times e to the negative 0.1004 times t. Okay? The K now is known. This is our K that we know already. Now we can solve for T. Same idea. 135 minus 70 is 65 equal to 380 times e to the negative 0.1004 t. And same step, divide both sides by 380. So 65 over 380. 65 over 380 is equal to e to the negative 0.1004 t. And then ln on both sides. 65 over 380 equal to negative 0.1004 t times ln of e, and then you solve for t. Is ln of 65 over 380 over negative 0.1004, and you should have the answer. So ln of 65 divided by 380 and then divided by negative 0.1004. About 17 minutes. 17.5.6 is approximately is 18 minutes. Okay. So if the pizza were taken out of the oven at 5 p.m., then at 5:18, then the temperature of the pizza will be about 135, and you're okay to eat it. Given that, you'll be able to wait that long. Okay? And that will be it for the second example. Let me look for another example for the logistics one. Okay? Okay, one more example. Look for a good one. Okay. Population of an endangered species. I'm talking about bald eagle in here. I see the picture. So they gave you the formula. We have formula PT is equal to 500 over 1 plus 83.33 e to the negative 0.162t. Okay? And we learned a formula already. 500 right here is the capacity we talked about all equal. Capacity. They say that they captured 6 of the bald eagles and they moved them to Montana. Okay? And that's the story. And let's follow the formula. Assuming that they don't tell you the original amount is 6, I claim that we can calculate it. We can figure it out by plugging the t equals 0. P0, initial population. Calculate what? Plug in t equals 0, right? Beginning time equals 0 is 500 over 1 plus 0.83.33 times e to the negative 0.162 times 0. So whatever times 0 is 0, so this is 1. This is equal to 500 over 84.33. And that's about 6. $500 divided by 84.333. Yeah, about 6. Since we talk about population in here, we're not going to have like 5.9 or 5.8. Okay, we have to have the whole eagle to work. That's about 6. Now that number is supposed to be 333, but they use 2 decimals, so it looks like that. Okay. Initial population. Have the calculator. Plug in t equals 0. Okay. Now here comes the main question of the problem. What is the capacity? That symbol. Capacity is the numerator right here. Capacity. C equal to 500. Means what? After a while, the maximum population for those eagles will be 500 at most. They're not going to get more than 500. Okay? Because up to some point, and as I say, given all the condition and the death rate and the airborne rate gonna be almost the same. What is the growth rate? Growth rate is right here. R is equal to 0.162. Okay. Again, the negative sign right here they put it because the rate is on the denominator. Say e to the 0.25 is the same thing. That's 1 over e to the negative 0.25. You see on the denominator, we have this negative in front. And it is about, so the rate is 0.162, which is about 16.2%. And what is the time unit for this? Let me look. Oh, year. This per year. So annually. Okay. So about 16% per year. So say 100 eagles in a year, it's gonna be 16 more. That's roughly is what I'm saying. The growth rate per year is from. And question C. What is the population after 3 years? All you do is plug in t equal to 3. You have the population after 3 years. 3-year population in 3 years is going to be 500 over 1 plus 83.33 times e to the negative 0.162 times 3. And of course, you guys going to need a calculator. Again, 500 divided by 1 plus 83.33 times e to the negative 0.162 times 3. And then I have to close the parenthesis and enter. It's going to be 9.5, so approximately 10 eagles. Okay. Keep in mind that those are living species, so you're not going to have in here. I got the answers is 9.56. I have to round it to the nearest whole numbers, about 10 eagles. Right? You're not going to have 9.5 eagles. Okay, so after 3 years from 6, you get about 10 eagles. Okay, and then the last question, no, not last yet, second to last. When will population be 300? Now they ask for the time. Start from 6 eagles, and they want to get to 300. How long does it take to raise from 6 to 300? So the new number is 300 equal to 500 divided by 1 plus 88.33 times e to the negative 0.162t. You have to solve for t. Okay, be careful. There's a lot of work in here. First of all, we're gonna get it the denominator. Multiply both sides by the denominator. We have 300 times 1 plus is 83. I copied it wrong. 83.33 e to the negative 0.162t equal to 500. Okay. We can simplify. Divide both sides by 300. 1 plus 88.33 e to the negative 162t equal to 5 over 3. 500 divided by 300. Okay, and then subtract the 1 on both sides. 8. Keep right 88, 83. 83.33 e to the negative 0.162t is equal to 5 over 3 minus 1, which is 2 over 3. Okay. Now you divide both sides by 33.33. I need some room to write, so let me erase this. E to the negative 0.162t is equal to 2 over 3 divided by 83.33. Okay. Now t is on the exponent. You want to solve for it. ln on both sides. So the left hand side is going to be negative 0.162t equal to ln of 2 over 3 divided by 83.33. Okay. And then divide both sides by that negative number. So t is ln of 2 over 3 over 83.33 divided by negative 0.6162. Now I need a calculator. One more time. ln 2 over 3 over 83.33 and then divided by 0.162 negative. So it's about 5 years. Is that right? Oh, no, I missed something. It's not 5 years. It's got to be longer than that. I messed up with numbers. Division, I did multiplication. I typed it wrong. Sorry guys, do it again. ln of 2 over 3 divided by 83.33 and then divided by negative 0.162. Now that makes sense. About 30 years. Okay? So to raise the eagles with the initial population from 6 all the way to 300, it's going to take about 30 years, given the rate of 16% a year. Okay? Alright, so that's pretty much everything in this section, and hopefully that makes sense to you. I'm going to stop the video clip right here, and one more time, thank you for watching. If you have any questions, please feel free to ask. Have a good day, everyone.